What's up guys, this is Massey. Welcome to another video. In this video I want to talk about finding magnetic flux. Magnetic flux is a scalar quantity and shows the amount of magnetic field, and it is shown by phi. Student places a horizontal square coil of wire of side length 5 cm into a uniform vertical magnetic field of 0.1 Tesla. How much magnetic field threads the coil? So when you want to find out the value of magnetic flux, we show it by phi, and phi equals to B times A times cosine theta. B is the strength of the magnetic field in terms of Tesla. A is the area perpendicular to the magnetic field, or let's say area of the magnetic field in terms of meters squared, and we have cosine theta. This theta is the angle between a normal to the area and the direction of the magnetic field. For example, if we have magnetic field in vertical direction and we have our coil rotated like that, so the normal line to this plane and the angle with direction of the magnetic field is gonna form theta. So the angle between normal to this plane and the magnetic field direction is gonna form theta. So if this plane perpendicular to the magnetic field, theta will be 0, so cosine 0 is gonna be 1. So whenever the plane is perpendicular to the magnetic field direction, we're gonna have maximum magnetic flux. So let's go back to this question and solve it. So first of all, I need to find out the area. It says a square coil, 5 centimeters, so it's going to be 0.05 times 0.05 because we need to convert it to meter, because A is in terms of meter squared. So when you multiply, it's going to be 0.0025 meter squared. So phi or phi B equals to B, which is given 0.1, times 0.0025 times cosine theta. Since it says horizontal square and the other one is vertical magnetic field, it means that they are perpendicular to each other. So theta will be 0. Again, this is going to be the angle between normal to the plane and the magnetic field, so it's going to be 0. Cosine 0 is 1. So therefore, we have 0.00025, and the units for flux is Weber. That's going to be the magnetic flux. And as I said earlier, that's the scalar quantity. So there is no direction for magnetic flux. Next example. Student places a horizontal square coil of wire of side length 4 cm into a uniform vertical field of 0.05 Tesla. How much magnetic flux threads the coil? So again, we use the same formula, B times A times cosine theta. Since one of them is horizontal, the coil is horizontal, and the magnetic field is vertical, theta will be 0. We need to find out B is given. B is 0.05 Tesla. We need to find out the area of the square coil. We have the length of it, which is 4 centimeter. We need to convert it to meter. So 0.04 times 0.04. That's going to give me 0.0060. In terms of scientific notation, it's going to be 1.6 times 10 to the power of negative 3 meters squared. So phi will be 0.05 times 1.6 times 10 to the power of negative 3 times 1. That's going to be 8 times 10 to the power of negative 5 weight. That's the magnetic flux. Next example. Here it says, student places a 4 centimeter square coil of wire parallel to the uniform vertical magnetic field of 0.05 Tesla. How much magnetic flux threads the coil? So what we have here, we said it's going to be B times A times cosine theta. B is given, which is 0.05. A is going to be given because one side is given, so 4 times 4 is going to be 16. 16 times 10, 1.6 times 10 to the power of negative 3 meters squared. And here we have cosine theta. But here, since they are parallel, the normal to the plane and the direction of the magnetic field is going to be perpendicular. So theta will be 90 in this case. So since the plane and magnetic field are parallel and theta is 90, we say cosine 90 is 0. So it means that magnetic flux is 0 as well. Now in this example, it says figure below is a perspective view of a flat surface with area 3 centimeters square in a uniform magnetic field B. The magnetic flux through this surface is 0.9 milliweber. Find the magnitude of the magnetic field. So as you see here, this is the perspective view. So if we show the direction, basically it's going to be B, it's going to be in this direction. And we're going to have the plane, something like that. And this vector is going to be normal to the plane. This part is 30 degrees. So it means that this part, this one is 90. So this part is going to be 90 minus 30. So theta is going to be 60 degrees. So if I write the formula for finding magnetic flux equals B times A times cosine theta. In this example, this one is given, B is not given, A is given, and cosine theta is given as well. So I'm going to say B equals to flux divided by A cosine theta. That's 0.9 milliweber. So it's going to be 0.9 times 10 to the power of negative 3 Weber divided by area, which is 3 centimeters squared. We need to convert it to meters squared, or square meter. It's going to be 3 times 10 to the power of negative 4. And cosine theta is going to be cosine 60, which is going to be half. So when you calculate it, the answer is going to be 6. Tesla is going to be the magnitude of the magnetic field. So you might have noticed that which B equals to somehow changing flux per area. So basically, we can say magnetic field strength is equal to flux per unit area. So that's why sometimes magnetic field is called magnetic flux density, because it's magnetic flux divided by area.